Only one.
And this is sort of one of views. And this is where does the Descartes res cogitans end?
Where what?
What is the border of the res cogitans? Should we take care about, or what do we mean by mind? It's the same question. Is it something what is only specific to us humans, as Descartes meant it, or as I am following you, I think mind in your concept is more like coextensive with life.
Is like what? Coextensive with life. Of course,
Bacteria have this kind of
well,
this what we call.
so Fatima, these are only huge questions, you know. First of all, nothing in what I've said, which is about quantum mechanics, excuse me for my voice, and the logical and ontological problems with mind and free will, tell us what mind is, what consciousness is. I think David Chalmers is right when he says no third-person description entails consciousness, including quantum mechanics. I'll tell you the view that I've come to. I think Chalmers has too. I suspect that quantum variables measure one another. Okay, so that fermions exchanging bosons are measuring one another. And if we were, so I'll take this in a couple of steps. Suppose we were persuaded that human consciousness is sufficient for measurement. We're not, but suppose we were. Suppose Radin's experiments were. Then we would have to, if we thought that was sufficient, we would have to say, so what else carries out measurement? Okay, I'm perfectly happy imagining that bacteria do. Okay, I'm perfectly happy with it, and Arabidopsis. But if it's the case that you make the move for which I can think of no evidence that quantum variables measure one another, I know how to test it in principle, then you get to a panpsychism that Spinoza talked about. If you bypass, we don't know that, if you bypass panpsychism, consciousness was there before there was life. And life has made use of consciousness just like it's made use of pressure and momentum. I think that's possible too. So do I think I'm conscious? Yeah, and I think you're conscious too. Do I think my dog is conscious? Well, he's not because he died, but I think he's conscious. If Radin could get his experiments to work, I could imagine doing the experiments by training dogs. I could imagine doing the experiments in all kinds of organisms. If it worked, he'd have a consciousness meter. Let me come back to your question. What's the edge of consciousness? My guess is it's quantum, poise realm, and classical. And consciousness is associated with measurement, either by decoherence or by quantum measurement. And that's about as far as I can get. What do you want to say?
For me, I have sort of that feeling that we should be somehow focusing, so we're seeking the border, but the border between the living and non-living.
Sure.
And now, what could be the border? One thing which comes to my mind is, where would these quantum phenomena become robust towards sort of providing information robust towards random environmental influences?
So we begin to have an answer. Excuse me for my voice. Vate has proved something very interesting. You can ask, how fast does decoherence happen? It depends on where you are on the x-axis. If you're chaotic, as Tegmark argued, decoherence is exponentially fast and it'll last a femtosecond. If the system is ordered or critical, decoherence is very slow. It's a power law. So it's really, really, really slow. Quantum critical molecules show power law decoherence. Light harvesting molecules do. So you've now got a reasonably robust, for a nanosecond, not a femtosecond, kind of quantum coherence. If recoherence is right, it may be the case that the exciton in the light harvesting molecule becomes coherent again. You could have a relatively long-lived, partially quantum coherent state. And I think we can maybe get evidence for that. I think critical molecules may be doing it. And that's about as far as one can go now. In fact, it may be the case that life is persistently partially quantum. And it may be that you can get agonist drugs out of this.
We might get yet another definition of life.
What?
We might get a new definition of life, let's say. It might be quite an important.
I don't disagree. I think it may be the case that life is inherently quantum Poisson and classical. And we are too. And we need it for definition of life along with molecular reproduction and other things.
What if this is a prerequisite?
What?
It might be a prerequisite, this part.
Yeah, I hope so.
Okay, first just a quick comment on the last question. I think the dichotomy between the life and non-life and seeking this dichotomy will be abandoned in 200 years as a dichotomy between the...
You're going too fast for me because I can't quite... Could you slow down? Sorry.
No, this was just a comment to Fatima's question, because I think the seeking of the dichotomy between life and non-life will be abandoned. As today, the seeking the dichotomy between human and non-human is to some extent already abandoned.
It's not, but
I'm not sure, maybe we are, too stupid to abandon this dichotomy, but I wanted to ask you another question, because I think there is a problem in the distinguishing between determinism and free will and, putting them counter each other, because I think you can have deterministic world and non-deterministic world, and you can perceive it's an inner thing that you have a free will and you don't have a free will. You can have deterministic world where organisms think that they have a free will because it's adaptive for them, to not feel that they are just pushed by the world. The one is external description,
Right.
deterministic or deterministic, and the other is the perception of the position in the universe. So I think that's two different things.
So can I restate what you said? The same issue can be raised for consciousness. And there's a very smart guy who said, why are we conscious? And his answer is charming. Namely, it's selectively advantageous to think that the world is enthralling. And that might be right. Actually, I'm quite persuaded I'm conscious. You're sitting there, right, and I can see you. I think all I can say with respect to what you're saying is, quantum mechanics seems to supply sufficient ontological conditions for free will, because you avoid the actualism of classical physics, and the present can have been different, and it is quantum indeterminate. That's pretty good. I don't think it tells you what will is.
Oh, yeah, I know that, but I think that also classical physics is sufficient for free will to exist, because it doesn't matter whether the world is deterministic or not. But I think that quantum mechanics, brings to the picture the fact that the world basically is not deterministic, which is good.
So do I think that you could be right in the sense that it's selectively advantageous to us for some reason to think we have free will? I guess so. I mean, certainly one can't disprove that claim. So a tentative yes, I guess, probably we would all think. I'm sorry for my voice, everybody.
I'm wondering less on the philosophical side and more about the implications for science of biology and how it's conducted. Thinking of the results that you are proposing that might be obtained from certain sorts of experiments. Let's say these were confirmed.
Mm-hmm.
Which kind of new avenues of practical research do you see this possibly opening up? And maybe also this goes to the question of how the quantum area of biology relates to your earlier research in self-organization in biology. So how can it redefine these questions? For example, criticality in biological systems is quite well known. And
yeah,
on the macro level, how does it relate to the quantum?
Yeah, it turns out that brains are critical. Dante Chialvo and others. And there's pretty good evidence now that cells are probably, genetic regulatory networks are probably critical. Less good evidence. So just some thoughts while I cough. fractal wave functions at the metal insulator transition is another kind of criticality. And just like you probably know that in random Boolean nets from brains, you get a power law distribution of avalanches of changing neural activities, a lot of little avalanches and a few big ones. Same thing in model genetic regulatory nets. You get a lot of little avalanches of changing activities if you flip a variable, and not many big ones. Fractal wave functions are doing the same thing. There is a local spreading of the wave function in time and space, but it doesn't go all the way across the system. It's not conducting. Somehow it feels that those got to be related. In any case, quantum mechanically, it says that the system, it's chaotic if it's conducting. I don't know quite why, but it's chaotic, let's say. Something that's very interesting about being quantum critical that allows a system quantum mechanically, if it's measured, it'll typically be measured nearby and very rarely far away with actual results. My own intuition, which is just an intuition, is maybe this allows a quantum classical system or a system being measured to have effects nearby pretty often and far away rarely, which gives the same notion of control without going crazy. So that's one thought. The other thought Gabor and I and some other friends are working on is receptor ligand complexes are treated classically. You familiar with this? Ligand complexes. People think physically classically about it. Do you know combinatorial chemistry? Here it is. Make millions of random molecules and see if anybody binds to something. That's the field. Just to brag, I actually have the founding patent on it, so I've thought about it for a long time. It became a huge field from which I didn't make any money or tiny bit. The amazing thing is that people have they put billions of dollars into making libraries of organic molecules that bind things, and almost no drugs have come out of it. And nobody knows why. It turns out that the drug companies stopped doing medicinal chemistry, which is QSAR, quantitative structure activity relationships. I've learned it, I've pretty much confirmed it. There's something called intrinsic drug activity, which is not just affinity, it's not just classical. Nobody knows why. Most people think it's some classical cloud of causal effects. I think it's worth exploring if there's something going on that's quantum mechanical. And there may be something quantum mechanical going on in receptor ligand complexes, and they may be in this poised regime. So I think we could try to look for making drugs in a new way and make combinatorial chemistry work. And I think that could be practical in the next couple of years. And in fact, Gabor and I and some others are trying to do it. So that would be at least two things to think about.
I might have a very stupid question, because I admit I have a hard time following your reasoning, because it's quite distant from what I'm making. But this is the question. As a biologist, we ask the question quite often in the kind of concept of the four Timbergian questions.
The four what?
Four questions by Nico Timbergen. You have basically the rhythm of life, which is the everyday life, and you really decide and digest the thing that's in ours. Then you have the ontogeny, then you have the evolution, and then you have the unique phylogeny. And all of these levels somehow are close enough, for me at least, so that we can see how they feed into each other. Whereas, you know, what you are describing, as far as I can understand, is like many orders distant from the smallest time rhythms that we investigate in biology.
You're right.
Or I'm wrong. Maybe
no, you're not.
So is there any, well, the previous question, is there any idea what kind of experimental work might be done which would somehow bridge this huge distance in the time rhythm in which these things are occurring?
No, it's not a dumb question at all. A few questions are, particularly by smart people. Let's look at decoherence first. Max Tegmark, who's an MIT physicist, said quantum mechanics can have nothing to do with light because decoherence is a femtosecond. And then the light harvesting molecule was shown to be coherent 1,000 times longer. That's amazing, and it's power law and all that neat stuff. But it's still only a nanosecond. The time scale of neural activities is milliseconds, right? We're a very long way to get from a nanosecond to a millisecond. And so I can just throw some scattered things at us. There's a man whose name is Stuart Hameroff. And Roger Penrose and Stuart Hameroff want to think that microtubules have something to do with consciousness. Stuart is working with a very good physicist who is finding rhythms in quantum mechanical oscillations in microtubules that span orders of magnitude from, I don't know, 10 to the 14th hertz to 10 to the 12th hertz to 10 to the 10th hertz to 10 to the 8th hertz. That's still much faster than a biological rhythm. Part of the problem, there isn't an answer for your question. Part of the problem, it seems to me, is this. If you ask physicists, how do you get the classical world, which I've done because I'm not a physicist, you get different answers from everybody. I suspect that nobody knows how you get the classical world, but they really don't want to admit it, because it seems like the table's here, right? The rhythms you're talking about are inherently classical. Yes, they're the rhythms of action potentials in neurons, or cell division, which is 8 hours or 24 hours or 32 minutes. I suspect we need the classical world for things to get that slow. But we need a classical world for something that's profound. We all know the Linnaean hierarchy. We all know that there's bones out there and bivalve shelves out there that fit the Linnaean hierarchy of higher taxa, right? You can't get that without a classical world. There have to be bones that can be mineralized that you can find in the rocks. So I suspect that the huge missing step is that I wish the physicists would say how you can get the classical world. I will tell you my own thought. There's something called the quantum Zeno effect. It's perfectly established. If you take a system and you measure it non-destructively, you measure it, and it's in a superposition of states, it falls to a single wave function established. The system then flowers new amplitudes, quantum amplitudes, very slowly in time, quadratically in time. Theorem. If you measure it again, if it's measured again very rapidly, almost certainly it will be measured in the same state it was in before. So if you keep measuring it very often, you freeze it in that state. That's the quantum Zeno effect. So I suspect maybe we can get the classical world in part by the quantum Zeno effect. I'm not a physicist, so don't believe it, but I'll tell you one experiment. Some physicists took rubidium ions and they put it at nanokelvin. And the electrons hop around by tunneling, which I vaguely understand. And they shine a laser at it. And as you increase the intensity of the laser, the electrons stop tunneling, as if by the quantum Zeno effect, as if they're being measured, as if they're getting kind of classical. They call it emergent classicity. I don't think it's well confirmed, but I suspect that it can be. If we could get to the classical world, then maybe we get to much slower rhythms. You know, rabbits and foxes do it in a period of months, right, in ecology. I just think you have to have a classical world. And this isn't a theorem, it's just a hunch. So the answer to your question, it's a fine question. I don't know the answer.
I just cannot resist commenting on the Penrose microtube idea.
Yeah.
I have to admit that I am sort of very skeptical about it, but might be you now probably closer to sort of realizing, sort of making a space for it again.
I agree with you, Vijay.
My problem
Yep.
is not with the microtubules, but with the connection to mind.
Sure.
As something specific to, let's say, us humans or as animals. Because many plants so full of microtubules. So you cannot sort of assume that something is the seed of mind or both of mind in the head of cabbage as much of it as our head. So what if we are
Yeah, good.
again, not at mind, but at something unique to life, and then we might have to look for mind somewhere else, and we might be getting some sort of fundamental property of living beings.
You might. So my own feeling about, I've met Penrose once or twice. I know Stuart pretty well. I don't think what they're saying is impossible. And basically they think that, Penrose thinks that consciousness is associated with measurement. Well before me, but after Wigner. He thinks that space-time breaks into two possibilities that then collapse by gravitational self-interaction in objective reduction. And then Hameroff came along and said, and it's happening in microtubules. That's not impossible. Suppose we did the Drosophila experiment I told you, and it turned out that the mutant proteins were in microtubules. I'd say, oh, that's interesting. That's possible. Meanwhile, you're willing to say E. coli is conscious, but Arabidopsis isn't? They're not moving. Huh?
I wouldn't call it consciousness. I would call it allied. Drosophila is allied, Arabidopsis is allied. By the way, light harvesting complexes, I am so glad that we are showing it on that, because there might be a nice evolutionary model. And now I am sort of mining someone else's knowledge, something what I heard on a seminar a week ago actually. But I learned that the light harvesting complexes are extremely diverse in evolution.
Really?
So yes. So in my career, I was looking at these proteins.
Oh, yeah, that's nice. I guess I'm incredibly skeptical, and I'm willing to entertain the idea that I'm conscious because I'm persuaded I am. You're conscious, I'm persuaded you are. Dogs are, frogs are, E. coli maybe is, plants maybe are. I don't know. We just don't know. Certainly plants are alive, and you're alive, and E. coli is alive. I think it takes molecular reproduction, and as Antonis mentioned, I've been thinking about autocatalytic sets of proteins for a long time. Gonan Ashkenazi has a 9-peptide autocatalytic set in Israel. By the way, that proves you do not need nucleotides for molecular reproduction. That's done. All that stuff. Yeah, that's all done. That's done. There's a guy named Niles Lehman who's trying to make autocatalytic sets right now out of essentially, well, I shouldn't tell you his experiment. He doesn't want me to talk about it. Not yet. I'm so sorry about my voice. Any other questions? Thank you all very much.
Thank you.